It's not very even, but it's going to get the job done. Let's go cut some steel. Hello Internet, my name is Quinn and this is Blondihacks. Sooner or later, every beginner is going to need to learn how to grind high-speed steel tool bits. Whether you have a lathe or a shaper or a planer or boring heads, lots of things in the machine shop need single point cutters and you grind them from high-speed steel. Now you've probably looked at all the books and maybe other videos on this topic and it can be pretty intimidating. You know, there's tables of clearances and rakes and angles for all different materials, and it can be a scary thing. I'm here to tell you it is a very easy thing to do with this simple method that I'm going to show you. Let's go. You're new to machining and you want to learn how to grind your own high-speed steel tool bits, right? Okay. Lesson number 1, don't. Pause for effect. Yeah, you heard me. I've said before on my channel that I think the best way to get started in machining is to buy one of these pre-ground tool bit sets. So this is a 3/8 set from Grizzly. Little Machine Shop also has a 1/4 inch set for smaller lathes. And these are a great way to get started because they have everything that you're going to need really for quite a while. And it saves you having to learn a whole bunch of complicated skills all at once. You've already got your hands full trying to learn machining and basic lathe work. You don't want to also have to learn the art and science of grinding high-speed steel tool bits. Furthermore, you know, when you're learning the lathe skills, you might be doing things wrong. You might be struggling with surface finish or, you know, chip breaking or things like that. And you don't know if you are grinding your tool bits wrong or if you're using the lathe wrong. You might be having speeds and feeds problems, but you think it's something to do with your grind, so you go back and try to grind it again. So eliminating variables will greatly shorten your learning curve. So get yourself some tool bits that are properly ground and you can learn one thing at a time. This Grizzly set, which I link to in the description below, comes with a left hand and right hand turning tool. Comes with this pointy, I don't know, I guess it's a grooving tool or something. I'm not sure what it's for, but it's got a sharp point on it, so it's good for getting into small spaces. And this is a boring bar, and this is an inside shoulder tool, and it even comes with a nice threading tool, which is biased to the left so you can get close to shoulders. So this is a great set, and it's got really everything you need for probably the first couple of years of your adventures on the lathe. Okay, but you're here to learn how to grind tool bits, so let's do that. Now there are tons of great videos on how to grind tool bits, and this is not going to be a master treatise. I think what I'm going to show you is how to grind the most basic lathe tool you need in the quickest and easiest way possible, and then from there you can build your skills. But what about carbide, you're thinking? Can't I just buy carbide insert tooling like all the cool kids use and not have to learn any of this dumb high-speed steel stuff? I think for hobbyists, the answer is no. Hobby machine tools generally don't have the horsepower or rigidity to really take advantage of carbide anyway, and carbide insert tooling is pretty expensive. Now, it doesn't seem like it at first because this insert here is $8, but you know, you burn up a lot of these when you're learning feeds and speeds. And this is just a basic turning tool. You're going to need threading tools and grooving tools and chamfering tools and lots of other shapes. So compare that to this humble piece of high-speed steel, which cost a few bucks and will probably outlive you. You can regrind this infinitely into any cutting tools that you need, and this will serve you extremely, extremely well. And sooner or later, you're going to need to learn how to grind high-speed steel anyway, so you might as well learn it now. And the other reason to start with high-speed steel is that it's simple. High-speed steel is high-speed steel. Comes in a couple of different grades or whatever, but there's just one material that you need to learn how to grind. Carbide is an extremely complicated topic. There are a million different proprietary chip breakers and coatings and compounds and sizes and shapes of these inserts. So you'll end up buying a whole bunch of them to find the ones that work for you and to learn all the nuances of them. And it's a pretty expensive proposition to learn your way through carbide insert tooling. So for beginners, I say high-speed steel is the way to go. Get yourself a pack of these blanks on Amazon. I've got a link to these down below, and I'm going to show you how to grind them. Now, I recommend starting here. Get yourself some square bar mild steel. This is 1/4 inch. You could do 3/8, whatever, but this stuff grinds much, much faster than real high-speed steel. High-speed steel is really tough stuff. There's a reason that we use it for cutting other steels, and so grinding it is very, very slow. So the nice thing about using mild steel is that you can grind it very fast and figure out, you know, the techniques and get the feel for the grinding wheel and how to hold your hands and so on. And you can make all your mistakes on this stuff and then move on to the high-speed steel once you feel like you've got the hang of it. Obviously, the fake tool bits that you make out of mild steel aren't going to be good for actually cutting anything. That's not what they're for, but it'll let you practice the techniques in a much quicker and less expensive way than on the real thing. But I am going to show you on the real thing. So when you buy these blanks, they come with one angle already in them. This is going to be usually 10 degrees. So the top surface above that angle is going to be the top of our cutting tool. This is what we're going to grind. It's a very basic turning tool used for steel, cast iron, and similar materials. So I like to start by putting some Dicam on there. And these Bingo Dauber bottles of Dicam are super handy for flat surfaces. They make a perfect application every time. There's a link to this stuff below as well. First step, set yourself a protractor at 85 degrees, a few degrees less than 90, and then just line this guy up on here so that this top left corner here, which is going to be our cutting corner, is right on the protractor. And then scribe yourself a line right there. That right there is our target, and what that's going to do is make it so that when this tool is up against the work, we're going to remove the area ahead of that line. It's going to keep the end of that tool from rubbing. For equipment, all you're going to need is a basic consumer grade bench grinder. This is a variable speed delta 8-inch, but the 6-inch ones are fine as well. I do recommend throwing away the gray crappy wheels that these things come with. Buy yourself some nice quality white aluminum oxide wheels. These are from Norton. The white ones are nice because they let you see when the wheel needs dressing, as this one does. And of course, make sure it comes with a dresser of some sort. This is a diamond surface here, and just press that guy up on there and hold your breath because it makes a terrible cloud of grit, and clean up the wheel. You also need a container of water handy. This is a Harbor Freight grinder stand that comes with this little tray here that you can fill, which is pretty handy, but if you don't have this, just get a yogurt container or whatever of water nearby so that you can dunk the tool bit in it when it gets too hot. The other thing you will need for my super easy beginner method is an angle adjustable tool rest on your grinder. Now, I made this one. I have a 4-part video series on this that I'll link to below if you're interested, but the factory ones that come with these guys are perfectly usable if they are angle adjustable. So this is the factory rest that was on here, and it had this little thing you could loosen and adjust the angle. So the angle adjustment is key. Quick safety note, grinders carry a lot of energy in them. This is a very heavy piece of stone spinning extremely fast, so give it your respect, and that means don't remove any of the guards. You see people running grinders often without guards on them. Grinding wheels can absolutely explode. A common cause of that is jamming them up. For example, if you have too big of a gap here between the wheel and the table and something gets down in there, jams it up, that wheel can explode. Also make sure you have the paper washers mounted on there. Those also distribute the clamping force on the wheel and keep them from exploding. And we all make our own PPE choices. Personally, in addition to eye protection, of course, I also wear a respirator when I grind. Grinding grit is impermeable. It will get in your lungs and sit there for the rest of your life, causing damage. Personally, don't want that stuff in there, so cheap insurance. I am going to start by dressing that wheel. Here comes the secret for my easy beginner method of tool bit grinding. And that is to set your table at 10 degrees down from perpendicular to the wheel. And if you don't have a scale or anything or any way to measure that easily, a simple trick is to just use the 10-degree end that came on the end of your high-speed steel stock and just line that up to the wheel like that, and just use that to set approximately a 10-degree angle. It's a little hard to tell, of course, because the wheel is round, but you know, get it in the ballpark. Now remember that 85-degree line that we scribed on there? You're going to use that to eyeball your angle. You're going to hold the tool flat down on the tool rest at that 85-degree angle that you scribed, and then you're just going to move the tool back and forth, and you're going to grind it down to that line, or until the front face meets up with the corner. Now this is going to seem to go really quickly at first because you're only grinding on a little bit of the tool bit there, but the closer you get to your line, the slower it's going to go as more and more material is engaged with the wheel. And you want to keep that tool bit moving so that you're wearing the wheel evenly, and occasionally it's going to get too hot to hold, and that's when it's time to dunk it in the water. Now you don't have to worry about overheating the high-speed steel. Your hands are always going to give out way before you're in any danger of damaging the hardness of the steel with heat. It's theoretically possible to do that, but you'd have to have hands of steel. So frankly, the dunking in water is just to keep from burning your hands on the steel. It's not really to protect the steel. Okay, away we go. So after that first set of grinding, you can see that we've got one continuous face on the back there. And you can see that the die cam turns yellow and mostly bakes off, but that's okay. We only needed it long enough to kind of get our muscle memory going there for the angle that we needed. Once you've got that facet started, it's pretty easy to find it again as you lightly press the tool bit up to the wheel, and keeping it flat on the table and just sliding back and forth also makes that much easier. So now we have the 10-degree front angle, and we've got that 5-degree sideways angle that we needed. So keeping in mind the die cam there is the top of our tool bit. So now we're going to take the tool bit and we're going to rotate it 90 degrees, and we're going to grind it again flat on the table into a depth of, something like that. And because of the angle of the table, right now only the bottom edge of the tool bit is touching the wheel. So we're going to grind in that way until the top edge is just touching the wheel. And then we will have a complete facet on this side of our tool bit. So with those two grinding operations, we are done. What? That can't be true, right? Grinding lathe bits is crazy complicated. There's 18 different angles. Well, this is essentially a perfectly usable tool bit for brass. And this is one of the many reasons that I recommend people start with brass as a machining learning ground, because one of the nice things about brass is that the tool geometry you need for it is very simple. The primary distinction for grinding tool bits for different materials is the top rake, the angle of the top surface as it falls away from the primary cutting point. And for brass, that angle is 0. So you don't have to do anything on top here. And I hope you see the strength of this method that I recommend here, because this angle on the end here is a compound angle. It has a 10-degree fall away in this direction and a 5-degree fall away in this direction. We got both of those at once by using the angled tool rest. And then this angle over here, which is a 10-degree fall away, was very easy to do just by holding it square to the wheel. So where this method really shines is that as a beginner, it saves you having to develop that skill of freehanding up here on the grinding wheel, which you'll see a lot of the pros doing. That's very difficult to learn to do at first. And in particular, after dunking each time, it can be difficult to find the face that you were on when you were grinding previously. And so you end up with like a polygon on the end of your tool bit, which isn't what you want. So the angled tool rest really, again, shallows up that learning curve for you so that you only have to develop the feel for that facet in one dimension. The table is doing everything else. So if you can just learn to find the facet you were on in this one direction, then you're good to go and you can grind a perfectly usable tool bit. And to prove to you this is a perfectly usable tool bit, I'm going to make some chips with it. But just before we do that, we want to deburr it. You can see that the grinding has left a burr everywhere on the edges there, just like any other grinding or cutting operation does. So get yourself a little Norton stone like this guy. There's a link to this in the description below. And then we'll just put a little utility oil on there and just kind of tidy that guy up. And after deburring, you'll notice that only the top and bottom edges of the facet are cleaned up by the stone. And that's because, of course, the grinding wheel has a radius on it. So there's actually a slight curve to each facet that we ground. But that's okay, because up here at the cutting edge is actually all we care about. Now, after deburring that, this guy is ready to go. However, it is very sharp on the corner there. And you always want at least a little bit of nose radius, otherwise that corner is just going to roll over immediately anyway. So again, just take your stone and just put a little bit of a corner radius on there. That's enough to get us started. Here's our humble new tool bit mounted up, and of course I made sure it was on center as I showed earlier in the Lathe Skills series. All right, enough talking. Time to prove that those two simple grinding operations made a perfectly usable tool bit. That was a 30 thou pass at 600 RPM, and the surface finish is excellent. Considering we have basically no nose radius on that, it just goes to show you how simple grinding a tool bit really can be. And this tool is very general purpose as well. I'm going to face this end next. And we got a little nub in there, it wasn't quite on center, but that's okay. Now, however, I'm really going to put my chips where my mouth is. That was a 70 thou pass followed by a 100 thou pass when it got into the full diameter material again. Wasn't even breaking a sweat. Could easily do more than that. So this is to prove to you that tool bits do not have to be complicated or difficult to grind. Okay, but brass is easy. Let's do one more grind and make it suitable for steel and cast iron and lots of other things. So once again, the wisps of die-chem here remind us that this is the top of our tool bit. And so the last thing we're going to do is we're going to make a surface that falls away from the cutting point both this way and this way. That's our top rake. And as far as beginners are concerned, this top rake angle is the only thing that matters for distinguishing tool bits for different materials. So we're going to turn this brass bit into a steel, cast iron, and pretty much everything else bit by just putting it down on our 10-degree tool rest like this over here on this side of the wheel. And we're going to do that same grinding motion that we just did for this facet. However, instead of just being square to the wheel, we're going to angle the tool bit upwards a little bit like this. So I'm not quite parallel to the front edge of my table here. I'm back like this a little bit. I'm exaggerating here. You only want about 10 degrees, even less, 5 or 8 degrees is fine too. And we're going to go ahead and grind that facet. And here's where we are after that final grind. As you can see, we got some deburring to do there. So we'll clean this guy up with the stone. There is a very general purpose turning and facing, etc. tool that will be perfectly good on steel and cast iron and lots of other materials. That last operation put a little bit of an angle falling down into the shank of the tool like so. So we did that compound angle just with the trick with the tilted table that you saw and having our hand slightly rotated, and that gave us this nice compound angle. So I'm going to put a little bit of a nose radius on this guy now. We've been working on the 60 grit wheel, but I'm going to come over here to the 120 grit wheel here because I'm going to put a little more generous nose radius on than we had for the brass. And you could also still just do this nose radius with the stone and that would be fine, but I want to show you another way to do it. Now I am going to freehand this, but if you have an adjustable table over here, the same 10-degree table trick would work here as well. Now this takes a very, very light touch because you just want to knock that corner off. You don't want much material removed there at all. And there's our little nose radius on there. It's not very even, but it's going to get the job done. Let's go cut some steel. So that was a 40 thou pass in steel, and that surface finish is excellent. Let's see if we can do a little more. Now that was an 80 thou pass, which is frankly about the most that I'd ever want to do on this little lathe. And once again, the finish is excellent, even though that was what I would call a roughing pass. And that was a very easy tool bit to grind. As you can see, with this simple method, you can grind tool bits for brass with just 2 operations and everything else with 3 and get excellent results. If you get lost while you're grinding, just remember that every surface needs to fall away from that cutting point. That point should touch the work and nothing else should, except maybe this edge here for deep cuts. This edge is working also. But that's the idea, is that you're just trying to make everything fall away. And once you're able to make this very basic tool, then now you can start looking at the books and, start experimenting with lead angles and nose radii and, different top rakes and back clearance and, all the other angles. But this basic setup that gives you just a 10-degree angle everywhere with a couple of simple operations is going to work for most jobs for the beginner, and it'll get you started on your road to grinding tool bits. Now, we haven't talked about aluminum yet. I got to mention that because it is a common hobby material. And if you look at one of these charts in the books, you'll see that all the angles are kind of in the 8 to 15 degree range, which is why I set that table at 10 degrees at the beginning, because 10 degrees is frankly good enough for pretty much every angle on every side of a tool bit for almost every material, until you get up to aluminum and all of a sudden it's crazy town. 35 degrees, 15 degrees. These angles sound enormous, and well, they are, so don't be surprised if your cutter comes out looking like a meat hook. This is what it is supposed to look like. That is a 35-degree top rake there, and that is just what aluminum needs. Aluminum is very soft and gummy and stringy, and you need a very aggressive rake on there to have any hope of breaking a chip. Now, with this type of cutter, mostly what you get is tight curls if you've got your speeds and feeds dialed in just right, and those tight curls will kind of fall down into the chip tray, and occasionally they'll break. Getting a chip to break in aluminum is not easy, but this aggressive style of high-speed steel tool grind will get you in the ballpark as indicated in the books. So once you've outgrown your pre-ground set, I hope you'll take the plunge and try your hand at grinding your own tool bits, and pretty soon you'll be making wacky shapes for all kinds of exotic purposes. Thank you very much for watching. I hope you found this useful, and we'll see you next time.